So this is a video just to represent how we would approach to implement the Fish Response Assessment Index. What we're doing is we're using a case study provided to us by Rob Palmer from NEPID, who has asked colleague scientists around the whole of South Africa to come together to demonstrate how they would apply these different indices. And this is just going to be a video of how we would apply our Fish Response Assessment Index. Yeah, and I'm going to be doing this with a few of my colleagues from UKZN, so you'll hear them jump in every now and then. Okay, guys. So just to give an idea, and you guys, please, you can stop me at any time to ask me any questions. So what I want to show you is what Rob has given us. Is Rob has said that they did an assessment on the 20th of February this year. So you can see it was in February, so it was during high flow period, at Mary Pebbles on the Sabi River in Mpumalanga. Okay, so that's where it was. What they've given us is these photographs of the different sections where they did these assessments, where they collected fish. You can see there were different locations where they sampled. And just to get an idea of the availability of habitats within using the photos. By the way, we don't generally ever do an assessment based on someone else's data or just being able to have access to photographs and videos of the sites. To apply this index correctly, you should be sampling the fish yourself, eh? You guys know that. Okay. So what I'm looking at when I look at photographs like this, when you do an assessment, is what is the distributions of different velocity depth classes. So I'm looking for fast deep and fast shallow habitat types. I'm also looking at different cover features like overhanging vegetation and cobbles, boulders, bedrock, nice substrates. And in the context of what fish may occur in this area and what type of habitats, in-stream habitats, they would be occupying. Okay. Can you guys see my cursor? Okay, great. All right. So the one bank seems to be modified slightly, but it's not excessive because the marginal zone itself seems to be intact. So there may be some impact from this bank impacting or affecting the state of the river, but you can see this line of marginal vegetation is still intact. Okay, great. Some nice photos to give an idea. So if you look at the characteristics of this reach of the Sabi River, it's higher up in the catchment, and I think what's important now is maybe just to look at where we are in South Africa. So they are working on the Sabi River. So this is our Sabi River catchment over here. Can everybody see this still? Okay. And where is the sampling area? So we're right up top here. Eh? Can you see that? Right in the upper parts of the Sabi catchment that goes outside of the Kruger National Park. You can see here's a built-up area. It goes through the Kruger National Park into Koromana Dam and then down into the lower Komati system. So one thing to notice is because of dams in the study area, you're not going to get some of your Catadromus migrating species coming up into the Sabi anymore. So that does give us some idea of what species that may occur. So where are we in the catchment? These are the two sampling areas here, sampling site A and B, and you can see what they've done is it's actually around the town of let's just have a look at that. It's around Sabi itself, the town of Sabi, in the upper part of the catchment. Lots of forestry, plantations in the area, plantations upstream, agricultural activities in the upper part of the catchment. There's some grassland areas that have been modified, and there's patches. You can see here there are patches of what seems to be indigenous vegetation along the rivers, but a large part of the escarpment area has been modified with plantations. And as it comes down towards the town of Sabi, which is just below the escarpment, you can see that that's where our sampling site is. This area called Mary Pebbles, which is a little accommodation holiday resort type thing. Yeah, upstream of this confluence over here, yes. yeah, there's another little stream coming in there. Oh, there's over there. And then it flows downstream. So it's flowing from this is looking from west to east. All right, and this is where they did their assessment over here. So that's what we're going to use to demonstrate Frai. So what you need to do is you need to get as much of an idea of what information is available to you for fish. And there's a lot of information that you need to evaluate before you do your assessment. So in this case, in the Sabi River, let's see what Rob has given us. Okay, so back to our photographs. Consider as well that this assessment was done in February, so these flows should be quite high, okay, compared to other times of the year. Okay, and you can see that the river, based on the photographs, the river at the sites are dominated by these high velocities. And I think that if you look at the Google map, you'll probably see that you would have high velocities for a large part of the study area, but you may have these isolated pools. So you would probably have a glide, riffle, rapid pool complex as you move down. So understand that their area is pretty high velocities, but you may have some pools around your study area, maybe upstream. Okay. Okay, that's where they did the assessments. Okay, probably high velocities over here, maybe, and quite deep water as well. I don't know if you've noticed that. Here's a nice cross section. So at the date of the sampling, they did a RAM assessment as well. And you can see that the discharge was 4.6 cubic meters per second, which is not bad, especially for a small stream like the Sabi. And then the depths range from 1.4 meters deep right down to 300. Is that correct? Is this meters? Yeah, it must be. Yeah. And then the velocities ranged from, what is this? Yes. You're right. So the maximum depth of the channel is probably about 900 mils. Just less than a meter. So that's 900 mils, and these are the velocities. So you're getting velocities of 1.4 cubic meters per second down to 0. Can you see that? 1.4 down to 0. So you've got fast deep, fast shallow, and slow shallow habitats across this one cross section. There is no slow deep across this cross section. You notice that? Okay. And then in terms of your substrate types, you've got cobbles, small cobbles, large cobbles, gravel, sand, silt, and clay. And using Professor Roundtree's classification system for substrate types, anything smaller than your fist is considered to be gravel. Anything smaller than your fist is gravel. It is coarse gravel or right down to fine gravel and then sand. But from your fist to your head is the range for cobbles. From your head to, if you could make a bow shape with your arms together, that would be boulders. And then anything larger than boulders, you would need to evaluate and decide whether that's bedrock. You with me? Okay, here's the assessment results. So what they had was overhanging vegetation. The availability of slow deep is 0. Okay, so where they did their assessment in February, they had no slow deep. Even though they've given it some ratings for overhanging vegetation and substrate, the rating for slow deep is 0. So we would assume that this means that there is no slow deep. No slow deep was assessed when they did their sampling. It may be because of the type of equipment they used. It may be habitat availability. But we have to consider that in this assessment, they did not consider slow deep. Slow shallow, very limited in terms of the assessment. Fast deep is very, very common. So this is a rating from 0 to 5. So you can see that fast deep was very abundant and very common. And you can see that where you have very high substrates like in-stream cobbles and boulders, that's where they did, that's the assessment that they obtained, and the related cover to that very high assessment. So fast deep is generally the most common habitat that they assessed. They also sampled fast shallow, and you can see it's not as common as fast deep, but they definitely had good substrates, good overhanging vegetation, or overhanging vegetation was available. And then there's just two columns of fast shallow, so we'll just look at the one. In terms of their sampling then, so we assume that this assessment of availability of habitats was only there for during the fast deep. Just give me a moment. All right, so then this evaluation of what habitats that they sampled is what you should fill out when you do your assessment. But in this case, you can see this is representative of the February 2019 survey. And based on the availability of habitat, because they're sampling the same site, you would assume that it's consistent, but there may be differences because the velocities may change. So they might have a much higher abundance of slow shallow, for example, not fast shallow, not fast deep. So you must just keep that in consideration because we don't know what they sampled, what the habitat availability was, and what the sample assessment was for 2017 or 2014. If you look at the fish species that were recorded, you can see that they have got these 6 species that I assume that they suspect should occur in the study area. Labia barbus nalspratensis. Wow, what's that, guys? So what's happened is this Labia barbus nalspratensis is the new name for Vericohinus nalspratensis. So it's actually Vericohinus nalspratensis from the Frai assessment perspective. It's just the name has been changed last year. So all the chisel mouth species, the Vericohinus, are now all yellowfish. Okay. Okay, so there's new yellowfish in South Africa. So that's Labia barbus nalspratensis, that's the yellowfish. Amphileus uranoscopus is the stargazer, and that's the mountain stargazer. The Chiloglanus anoterus is a little sucker mouth with a long tail. Oncorhynchus mycis, who knows what that is? Yeah. And then Pseudocrenilabrus philander, which is the mouth brooder, southern mouth brooder, and Tilapia sparmani is the banded tilapia. Really interesting results. If you can see, just look at the abundances of yellowfish and stargazers, or the Chiloglanus that they obtained in 2017. So yeah, so they've been collecting huge abundances of yellowfish and stargazers, and wow, wow, that's interesting. 51, 64, 10. September, October, and February. You're right. Well done. So you may be getting fish being forced into these habitats during low flows in October, but you would not. Why would you expect a lower abundance during high flows? You see, that's the question you must ask: is this a natural representation of changes in the system, or is it possibly because the flows are much greater, the availability of habitats is improved, and the fish have actually moved away? You with me? So there's a possibility that because they don't have any other comparable assessments during February, that during this time of year, your fish may be occupying different habitats upstream or downstream of your sampling area, and they may all come and congregate during September and October, especially if this is a critical site. Okay, so when people do their site selection, I'm going to go back to this map. What they generally select is what they refer to as a critical site, where you're going to have a good representation of habitats that have to be representative of the reach. But what often happens is that you find an ideal habitat, which would probably act as a refuge area for many species. So you expect to find a lot of them during winter, but as the flows increase, you may actually find that these habitat areas upstream and or downstream may also be quite ideal, maybe ideal for these different species. And during the high flow periods when they did this assessment, that may explain why the abundances are lower. Okay, so from an abundance perspective, it's important to consider the differences. But presence absence is key. And the fact that they collected some stargazers in 2017 and they've collected none in 2014 and none in 2019, that's probably concerning. You know, the fact that you should be collecting stargazers consistently is probably some indication that there may be something going on. And that's what we're going to consider in this assessment. Are you with me? Yeah, exactly. So from a quality perspective, Trout would tell us what's the quality of the system is, but we must consider that they're an alien species. So the fact that we haven't found any in 2019 is probably good news. But if it's not there because of their response to altered water quality, then that would probably be an indication that the river has also changed. So, number of species and no cichlids, by the way, they didn't collect any cichlids. Also, bear in mind that these yellowfishes, we consider that they should be migrating, or they do migrate, and during low flow during winter, you find very high abundances of these yellowfish in the study area. So that does suggest that there's lots and lots of juveniles, and you may have a larger a refuge population of adults downstream that should actually have migrated up into and possibly be using this habitat area during summer. So I would actually think that the fact that they've got fewer yellowfish during summer, knowing that these fishes migrate and they come up into these areas to feed and to spawn during summer, was also a little bit of an alarm bell saying that maybe something is going on there. Okay, so just keep that type of information in. No, exactly, and just bear that in mind as well. So I'm trying to tell you what I'm thinking, but you wouldn't have that information. Yeah. So there's two cichlid species that they've not observed at all, and then so the number of species has gone from 3 to 4 to 2, which is not a massive change. It's not telling us a lot because you don't have a lot of species. So you're going to be relying very heavily on your yellowfish and your chiloglanus. And then the number of individuals, wow, look at the balances. That's come right down from 159 to 10. But I would also look here at this effort. So you can see that in terms of your electrofishing time, this is also probably the highest flows, but the lowest effort. Do you understand that? So if you had almost doubled your effort to about 30, can you see here? Look, this is more than double the effort. And then they got a lot higher abundances. So you do expect these abundances to go up. But if you do divide that by the time that you've sampled, which is referred to as catch per unit effort, you would see that during the first survey in 2014, they collected on average 1.7 fish per minute of sampling. And you can see it's only electrofishing. And then during 2017, they collected almost 7 individuals per minute. And then in 2019, it's 1.13. So if you compare 1.17 and 1.13, it's not too much of a change. So that's taking the differences in time into consideration. But if you look at your indigenous species, going from 1.6 to 1.1 is not massive, but they generally had a very good year in 2017. So you'd also consider, is this a bit of a fluctuation? Is it going up and down and up and down? Okay. All right, that's what we have from a fish perspective. So what we need to do now is we need to go and apply our Frai assessment. And there's a few things that I want to show you is this is the Frai tool. So it is an Excel-based tool. And you can see this is, I'm going to start with the old Frai 1. And then I'm going to just use Frai 2.0 a little bit later just to give you an idea of the differences. So it starts with the scientific names. You've got your intolerant species table. Let me just make it a little bit bigger. Okay. And then you look at your frequency of occurrences and your changes in frequency of occurrences that you have obtained for the different sites. I'm going to show you how we'd look at that based on their data. And then you have all of your all of the different metrics that you would be able to evaluate how that community, based on the preferences of the different species, could be influenced based on the presence, absence, or frequency of occurrence of different species. Let me repeat that. So all of these matrices, what they're doing is they're looking at different attributes of fish communities, their preferences for velocity depth, their preferences for cover, their preferences or their response to modified flows, their preferences or responses to modified physicochemical conditions, and migration requirements. And what you would do is you would look at the assessment involves reviewing the species that you expect to find and their preferences, and the species that you did find, and whether or not you're getting some consistent indications based on the preferences of species that there may be problems at the site. In other words, if there was a water quality problem, all of the species that have a high preference for water quality should be affected by that change in water quality. And you should see that based on your changes in your assemblage. Are you with me? Okay, so that's just an idea of how we're going to do the assessment. So we're going to go through all of these different indices, all of these different matrices, and then do the assessment. Okay, but before we start, we need to make sure that we've got a good representation of what is the expected fish distribution list from this area. So what would you do in Pateni, for example, if you don't have those species that have been obtained by Rob Palmer's assessment? How would you know what occurs in the study area? How would you know what is indigenous? How would you know what is alien? How would you really know what to find in your area? Okay, so the first thing that I would do is I would go to the PES EIS database. Okay, and let me just show you what that looks like. So, see, is it still going? Yeah. So this is what it looks like. You would open primary catchment X. How do I know that? Because if I go to Google Maps and I import the different water management areas, which I've done already, this is catchment X, which is the Nkomati Usutu catchment, which includes the Sabi, the Sand, the Crocodile, and the Komati River. Okay, sorry, let me just tell James I'll call him back. Okay, the next thing is to get an idea of where we are in the catchment. Now, what the PES EIS assessment has done is they have already reviewed all of the different. Oh, it's persistent. Okay, just give me a moment. Let me just. Okay, so if we get back to it, what I want to do now is I want to go to the PES EIS assessment and find out what is in that area. Now, the PES EIS assessment, fortunately, is labeled to show you that X3 is the Sabi catchment. So if I open the river codes for X3 on Google Earth, you can see that it actually maps out where each of the resource codes are. So what happened is people worked, scientists have come together and they sat around in a workshop setting to work out what would the current state be based on habitat availability and land use, and what would the probable species that would utilize these different areas be, and the PES EIS has given us that, so we can get a lot of information from PES EIS. Another thing I want to do is I want to open the fish sampling location to see where the closest fish sampling points are. And you can see, I opened the wrong one, X3 fish. There we go. And you can see that there have been a lot of fish that have been sampled, and that data is available in the database. Can you see that? So I know that just downstream of our study area and upstream of our study area, a lot of data has been collected. It's real data. If you right click on that, for example, no, yeah, here it is. Sorry, it's just hiding from you. Then you can see they collected Barbus anoplis, they collected philanders, they collected sparmani, and they collected the vericoenus. Can you see that? Okay, so anoplis is a Enteromius anoplis now, is a species that has been collected in the past right here, but is not included in their expected reference list. Do you see that? Okay, so the first thing I want to do now is I want to start taking notes. So I'm going to take notes. File, new. Okay. And okay, the first thing I'm going to do is get the property, the right click there, and say this assessment. They collected B anno V now, and what was the last one they collected there? T-Spa. PP and T-Spa. Let me just take all three. Do you understand what I'm doing? You need to justify what you're doing. Historical fish data. Okay. Then if I go downstream here, I want to see what was collected here. Can you see that? And if I look at the properties here, it's Anoplis and the yellowfish. There they collected CNO. Oh, that's Chiloglanus onoturus, trout, and the yellowfish. Let me collect that as well. Okay, and you can see that the reach code is very similar, and I'll say this is upstream, and this is going to be downstream. This is just historical data to say that they've been sampling here before and they've collected this data. That's all. Yeah. But all I'm trying to do is say historical data obtained from fish data in PES EIS. Yeah. And that's why if you did the assessment yourself, you would need to go and get a better idea of what's going on there. And look here. Here they've got Amos. Look at that. Can you see that? What's Amos? Anyone? Yeah, it's a pity we don't have the date, but it just shows you that they have collected eels there. Okay, so that's what I'll do, and then I'm going to highlight that in red. I'm going to highlight that in red as well, because those are the two species that they don't have on their list. Okay, and then add here B, Ano, and A moss collected here historically. Okay, ref PES EIS fish data. Okay, done. The next thing I'm going to do is what I do is I'm going to do look at my IUCN database. Now this is just if you've got if you really have no idea of what's occurring in your study area. So in Mpateni, this is what we did for you: is we looked at the IUCN database, and you can see here what it is it's a database of all of the fish species that have occurred in South Africa. And you can see here is my Sabi River catchment, and within the Sabi River catchment, I want to know what are the species that occur within this catchment. See, but unfortunately the resolution is not very good. If you put the rivers in over here, we're actually working right up here. Okay, so we're actually working right up here by Mary Pebbles. I looked at this just now, guys, just to see exactly where we were. And what you can do is you can actually go and label the samples to see where what has been collected in the area. That's just where they're being sampled. I'm just going to change the label to the taxon name. Sorry, I've got a lot of things running, so you can see my computer's just struggling a little bit. Taxon, okay. Okay, and what have we got? We've got Amphileus natalensis. You see, they said there's only Amphileus Uranoscopus. There's lots of anoterus. So in other words, the question would be, do I think it was Natalensis? Because this is outside of the Natalensis range. So I think that that should be Uranoscopus. So I'm not going to put too much weight on that. Exactly. Look at that. So here they've got labia cylindricus, 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 and they've got Clarus garipinus. Okay. They've also got vericohenus again, which we expected. Amphileus natalensis, vericohenus, vericohenus. So again, here, the new species that I think have occurred in this study area could be the labio cylindricus and Clarus garipinus. Do you see that? So again, now what I'm going to do is go back to my documents and say from IUCN database, and this is Scott et al. 2006. That's the reference. There's museum records of labio cylindricus. I started right. Yeah, and Clarus garipinus. Okay. And then again, because we're using Frai, this would now be this would be LCYL, and this would be CGAR. You with me, guys? Okay, and then I would also like to just go downstream a little bit and see if there's anything else that they picked up here. Vericohenus, chyloglanus, and oterus. So you can see they start becoming more abundant as we move downstream a little bit. Not too far, just to get an idea of is there anything. Then they're starting to get Marcusenius. Can you see here? And now you're getting all sorts of new barbs and things downstream. Yeah, Mariquensis. So I think that's too far already. You see that? So I'm not going to move too far. What you could have done, by the way, is another way of doing this is to select your catchment. Okay, select your subbasin. So let me just turn those labels off. I've selected the subbasin, and in this database you can go to open the attributes table. Let me show you what that looks like. And then you can select the linkable tables. So it's going, this is just a spatial query to look at the species that occur in the whole Sabi. This is this list of species from the whole of the Sabi River. Okay, so that's a problem because it doesn't tell us which are lowland species, which are temperate species, for example. And you would have had to do the same thing, going to each of the specimens to see where they've occurred before, and or you would have to go through skeleton and see, okay, this is a temperate species, this is a lowland or tropical species, and they would occur in different parts of my catchment. Do you understand that? Okay, so with this data now, you could have, you could take this data there, because it's linked to this specimens list. Darn it, I've closed it. And you could export that data as a list. So that's how we determine what species have ever been observed in your study area based on museum records. That's very valuable. So in Patanian, guys, if you do this assessment, go back to this video and just have a look slowly. And if you need to look at what are the species that have occurred in your different subcatchments, then I can just print out a list for you. Okay, I can also just give you this data. This data is available from IUCN or from SciAp, but you can get the list yourself. How does that sound? All right, so now we know what to expect in your study area. So I'm going to go back now to my Frai sheet, and this is my Frai assessment. And now I know that what I expect to find, so based on this data, my expected expected um, um, species distribution and frequency of occurrence is, and I'm going to list what they've collected here now. So by the way, if you collect new indigenous species, like for example, if I didn't have their assessment, I would not have known that these cichlids occur here. Can you see that? So I would not have known that the cichlids occur here. And well, can you see that we've actually found that Pseudocronilabris philander has occurred in the list? Oh, let me explain that. What a good example. Sorry, Matt, I almost missed that. So the last thing you should do is you should open this PCIS sheet. Let me just close mine quickly so I can show you how they did that. So what you would do is you would go back to the PCIS data and you would open the X3 SABI PCIS sheet. Okay? And it looks like this. Just see where it's going to open. Yep. And then here you can see that this is the database from PCIS. This is what everybody is probably using. And if I go to unhide and I unhide my fish data, okay, then here is all of the list of the fish that have been collected per reach of the Sabi River. You with me? Okay, so here what I would do is go back here and I'd look for this reach. The reach code names are not there. So let me just fish. Let me just turn this off. Go back to PSIS, look for the reach code. Okay. And then here you can see I'm dealing with X31A 00778. So I'm going to write that here. Is it 0778? Let me just check again. 00778. Okay. And I also want to consider this reach downstream here. I don't want to go too far. Can you see? That's where we started collecting all of those other species. Down here. From the confluence where you started collecting the other Interomius and the other yellowfish and things. So I think that's too far. So I'm only going to focus on this reach and what I would find in this reach. So it's X31A 00778. Here we go. 00778. Can you see it's that one? What you can do is you could have put on your filter. Don't know why it won't go on. Oh, it's on already. And now deselect all, and then you go into this list, and you can type in, I want to look at X31A 00778. Can you see that? Did you see that, guys? So what I've done is I've opened the PCIS database. I've gone to unhide, and I've pressed unhide, and I've gone to find the fish list, and that's this new blue one. I've clicked on the fish list. I've gone to the subcourt level. I've opened that, and I've looked for my X31A 00778. Everybody with me? Okay, now I know what species have been collected here. And here they tell you they have collected Natalensis, Uranoscopus, Anoplis, and Amos. Now you must argue again why you're doing what you're doing. So I'm going to add here and say from IUCN database, museum records of Al cylindricus and Carapinus observed in X31A. Based on this added to expected species list. Okay, and here, OMOS collected where historical reference there. And then here I'm going to also add U natalensis, also historically collected, but unsure, but uncertain of species identification, and that AURA hypothetically has similar preferences. So for Frai assessment, I have not included ANAT.
I just changed it.
ANAT is what I'm not including, but I am including URA. Oh, well, thank you very much. That's wrong. That's Amphilis natalensis, also historically collected. Okay, cool. And then I think that we've got all of our species. So based on my assessment, this is what we propose. I'm going to just change this to their Frai abbreviations, which is VNEL. You must look at the list if you don't know what they are yourselves. A URA, C ANO, OMYK. Then I'm going to do PPHI. Oh, I'm also going to say here, by the way, is YPP. So if I go back to their list of their database, if you go across here, look here, they've got AMOS, okay, they've got ANAT, they've got AURA, they've got BANO, which is Enteromius anoplis, BANO, they've got CNO, which I've got. Then they've got PP here. Can you see here? They've got PP. And what they've done is they've said that it should be a 5. So there's no comment here. But if you look at what 5 relates to, let's just type in edit comments so we can see what they're talking about. 5 is present with high confidence. The species has recently been recorded in the sub-reach. So if it's there and it's a high presence, then we've assumed that they've got information that it occurs there. So does T-SPAR and so does VNUL. Okay, so I'm going to say here, although there is no museum records or evidence of PP and T-SPAR collected in this reach, and then I'm reference fish data from PES EIS due to high confidence in PCIS tables, I've included them in this assessment. You with me? Okay, so now I've got PP, I've got T-SPAR. Okay, is that now, and then I've got oh my kiss. Oh, I've got that already. Okay, so I've got 2 cyprinids. I've got Anoplis and the yellowfish. I've got a stargazer and one suckermouth, the rock catlet. I've got the alien Omycus, and I've got the Sparmina. What else am I missing? I'm missing Cylindricus, LCYL, and I want to put the catfish in with the other siluriforms CGAR. You with me? So this is my expected species list. Okay, and for a report, I would actually write this out. So I would write this. You see, I would write that out because then you've got their genus and species names. Do you understand? Okay, so for now I'm going to take this list and I've justified why I'm doing it, and I'm going to populate that into my Frai expected occurrence list. And the first thing I want to check is, let me just, sorry, I'm just going to do that again. I want to paste it as, paste special as Unicode text. It must just be text. So the blocks must always stay gray in the background. If they change color, that's not right. So what have we got already? We got some indication of the velocity depth preferences of anoplis, flow intolerances, cover features, all that, and migratory requirements of some species. And you can see here that some of them have got 3s and 1s. So we've got species that migrate, we've got species that are important, intolerant of modified water quality. There's 3 species that will respond to modified water quality. And yeah, okay, so we've got a pretty good idea of what, that's what we're going to say represents our reference list. Then what we do is this now recommended, the reference frequency of occurrence is what you need to populate, and you need to compare that to the frequency of occurrence that you've observed. You with me? So what we do is based on our assessment, and if you look at the scoring here, has it been present at a few sites? So we're looking at what is the probable distribution of these species in your area. Would they be very common? The frequency of occurrence be very high, and they're quite common, and they occur at many sites, and that would be from a score of 5 if almost all sites, and you expect to collect them 75% of the time. And or would they only occur at a very few sites? Now what I do is I consider along that reach, what would the, especially if you go into the field, guys, remember, you would actually need to have done a bit of a walkabout and considered here to say, how unique is this site to the reach? Because if this site is dominated by high velocities, that suggests that these areas over here, there might be a lot of pools and other types of habitats, which would provide for other species like your cichlids, for example. And then you would consider, if you came and did an assessment here, how common would those species occur along that reach? And I would probably think that you would get areas where the cichlids would be more likely to occur than this area over here, which is where your high velocities occur. So this reach is dominated by relatively higher velocities. So I would think that the species that have preferences for higher velocities would be a lot more common than the species that aren't. Okay. Are you with me with my rationale? Yeah. So I would go back to this fast deep, fast shallow, and think that all of these species except these guys here, they would be, oh, it's that one. It's actually the Clarius as well as the 2 cichlids. They would not be as common as the others would be. I would also consider the flow intolerances, the cover preferences, and where you've got species that have got high preferences for overhanging vegetation or those that aren't. So you would do an assessment, just a simple assessment to say, based on your habitat availability, so frequency of occurrence. So a reference FROC determined using availability of fast velocity depth profiles and substrate types in relation to reach I'm going to say hypothesize. Can you see that? So I hypothesize that this is what it is. based on substrate types in relation to reach. Used simple Google Earth videos and site data. By the way, did I show you that if you go back to Rob's photographs, did I show you the YouTube video? Okay, let me just show you that quickly. Just have a quick look, because this will give you an idea of how common these different habitats are. Can you see it? See, high velocities, rapids, glides, all the way up. You might get some slower flows here amongst the margins, which is what the cross section shows. See, that's what they did the cross section. Hey? Exactly. I can see Rob sitting in the car there with the screen on. Very high velocities here as well. So they would have gone in and sampled available habitats. And I suspect during February you must have had very high flows. And you can see what they've done is they've actually marked off where is the upper and lower extent of the sites. So you can see where they've been sampling and what they've been sampling. There's some slow habitats there, some slow habitats probably under here. You can see there's even fast habitats under the vegetation here. Okay. So based on the habitat availability and the preferences of your species, what do you expect what do you hypothesize their reference frequency of occurrence to be? And I think what's very useful is to look at and to put those hypotheses down. You can see there's some slow here, but there's no cover there. There's probably a little bit of cover over here. Okay. All right, let's go back to our Frai assessment. And what I'm going to then base the assessment on is how common is Anoplis. And if you look at Anoplis, they've got a preference. They don't like very fast flows. Can you see that? They don't like very fast flows. They like slow flows. Whoopsie, no. And in terms of substrate types, they like undercut banks, they like cover, and they like macrophytes. So based on that information, I would say that they're quite rare. So my reference frequency of occurrence would say that they are not very common at that site. You understand? Do you agree with me? Okay, how about the chisel mouth? Like fast flows, like cobbles and gravel and boulders, they should be very common. Should you occur them everywhere? I'd go back to what they've observed and say they've actually been occurring them very consistently. They've collected them all the time. So I would say yes, that's very consistent. How about your labio cylindricus? Well, here I would say that under natural conditions, because your reference must be reflective of natural conditions. In fact, all of these species like high velocities and frequency and fast deep and fast shallow, and they also have this preference for substrate types. You can see that very high preference for substrate types, just as high. So they're very similar. All of these, the yellowfish or the chiselmouth, the labio, the uranoscopus, and the chiloglanus are all very common. And they have a high preference for those sites. What I would consider here as well, though, is just consider that the yellowfish and the labia migrate, and we know that they would not be here as common all the time. So I would probably give this more of a 3 or a 4. Let's give it a 3, because I'm erring on the side of caution, because I know that they haven't been very common, but they have occurred there once. The Amphileus uranoscopus should be very common, so I'm giving that a 4. The chiloglanus is super common, a 5. And I think in our case, let's just give them 3s and 5s. So where you've got very low confidence, I wouldn't rank twos and fours, I would just give it a 1, a 3, or a 5. And you can say, based on your uncertainty, because you're not there and you haven't done a detailed assessment, you're just going to give it 1, 3s, and 5s. You with me? Clarius doesn't have habitat there, so I'll give it a 1. Philander doesn't have habitat, a 1. Sparmanni doesn't have habitat there, give it a 1. And then your your trout have also preferred high velocities, good substrates, good cover. They don't like water quality changes, but naturally that would be fine. And Pateni, I just want to suggest to you that when you do your assessment, some cases when you look at your expected frequency of occurrence, if you're working in the lower parts of your rivers that are naturally have lower oxygen levels, the water quality is not as pristine as it would be in the upper catchments, or not as relatively as good as it would be in the upper catchments, you would consider those species that have got very high preferences for water quality and give them a much lower expected frequency of occurrence in the lower parts of the catchment. Are you with me? Okay. All right. And then for this assessment, if you got 0, you would immediately get an automatic Frai score of an F. Do you understand that? An F. So the frequency of occurrence, how common were they and how often did you find them? You got nothing and you would get an F. If you got the exact same score, you would get an A. Do you understand that? So exactly what you expected, you found. So the automatic Frai assessment is only based on the species that you found, that you expect, and whether you found them. And if you find all of the species, they should be there, and you will get a perfect score. Okay. Even if you do consider getting 5s for everything. Oopsie. Let me just give that a 5. Can you see what it's starting to do is it's saying that based on your expected availability, you collected everything that you should have expected, but based on the availability of habitats, something has changed. Because if you're starting to get 5s for your cichlids, where you were only expecting 1s, something has changed, which is now causing there to be 5. And that's probably reflective of a altered system, a community structure as well. Do you understand that? Are you guys there? Oh, I think I've lost them. Okay, so everybody's there, hey? Yeah. Okay, so what I'm just trying to suggest is that it's very important to give a realistic score here, because if you go and you do your assessment and you come back and say, you know what, I only thought that Amphilius should be a 3, but I actually collected them all over the place, and I actually think that they should occur all over the place, then you must adjust it and say why. You with me? Okay, so now for my my comments sheet, I've got a little bit more data. Okay, so I've got let me just do one more. Okay, can you see what I'm doing here? I'm just putting my I'm making a table of from my Frai sheet of ABR abbreviation, species, and this is frock, but this is my ref frock, and then I've got an OBS frock. That's my observed frock. You guys with me? And then I just want to change this to Labiobarbus. So I want to make sure that everybody's using the right terms. Yeah. Sorry, and then that's got to go there as well. And then here I'm just going to say that this is an alien. Alright, you with me? Now what we do is we go back to our Frai sheet and we look at what they found. Now, We're doing an assessment for 2019, hey? 2019 only. We're not doing the assessment for the last 5 years because lots can have happened in the last 5 years. But we need to get an idea of, based on the availability of habitat, what did they occur and how frequent would they have found them. So the fact that they found yellowfish, and beforehand they found them very common, and you can see that the sampling catch per unit effort has gone down. I would actually expect that that effort that would have been probably 5 has probably come down to less than 5. Similarly, but not by much, similarly the Chiloglanus onotrus would have come down from a 5 to something just slightly less than 5. So in this case, I'm going to say that my Verrucohenus, sorry, let me delete those again. My Verrucohenus is a 4, and my Onoturus is a 4 as well. Can you see they've been quite common? So I've not found one. And in terms of the effort, you're catching an effort similar to what you've had in the past. So it's not 1. It could be a 3, but it's not 1. Are you with me, guys? Yeah. So I wouldn't give it a 1. Now, what else did you find? Did you find anything else? Hey? Yeah. What's your question? Hmm. So what I've got to do, what I've got to do, what I've got to do is based on when you go do your assessment, you've got to go there and actually look at habitat and the number of individuals you collected for different biotopes or different reaches that you sampled. And if you look at the Frai guideline, what Niels would have required you to do is select a few sites within that reach. What the guys who did this assessment have done is they have sampled many different habitat types, but between their reach of point A and point B, the video I showed you. So they would have gone through that whole reach and sampled the different habitat types, and they would have collected these individuals, this number of individuals. So they would have sampled multiple fast deep habitats and multiple fast shallow habitats. Do you understand that? And from that assessment, you can see that they collected 7 yellowfish and they collected 10 catlets. Now, in 15 minutes of sampling, you collected 7 and 10. That means that there were a few. There were a few in the different habitat types. So if you go back to your Fry assessment, you need to answer, were they present at very few of those sites or those habitats within their reach? Were they present at a few of those habitats within their reach? Were they present at about 20 to 50% of the habitats in the reach? Were they present at most sites? And were they present at almost all sites? So one thing's for sure, because your catch per unit effort has come down, I definitely don't think that we're talking about 5s. Because your catch per unit effort is not 0,0001, I definitely don't think that we're talking about 1 either. So I think we're definitely talking in the range of 3s and 4s, or do you understand? And that's what I need to do. So I don't want to just say that they're there and give it a 1. I've actually got to say, how common were they? And I want to hypothesize to say that they were actually available at many of the sites. And I think that if you look at the score of 20 to 50% of the sites, they definitely at least make a 3. Oopsie. But the question is, does this Chiloglanus make a 4 or more than a 3? And I think if you look at the catch per unit effort of your indigenous species and what you collected historically, it's not far from what you would get historically, which would actually represent 5. So that's why I think that there's probably more of a change in my yellowfish abundances than there were in my Chiloglanus abundances. So you can actually give it a 3.5, or it doesn't like 0.5s. So that's why I'm just saying I'm going to err on the side of caution and say 4. Okay. Now what about the rest? Did you collect them? Do you think that they're there? Well, I've got no data to show that. So I'm going to say 0. I'm going to say I've got no data to show that they were there. And if I go back to my Fry assessment justification sheet, I'm going to say that that this was a 0. Okay, let me just put the zeros in. And I'm going to say, just for my Chilodglannis, I collected a 4. And for my Verrucinus Nauspratensis, I collected a 3. Okay, so based on reference frock and observed frock, automated Frai score is equal to, and you get it already, you get a 35.07, which is a category class E. Here it's automated 35.1 and it's a class E. Okay. The problem is, do these fish really not occur there? And if these other fish that don't occur there, are they not there because the conditions of the ecosystem have changed so much that you do not find them anymore, and that this class E is realistic? The question is this class E realistic or not? Well, there's an opportunity for you to go and adjust the score. Okay, so what we're going to do is we're going to process to adjust automated Frai score. Yeah. Um, yeah. Exactly, Matt. Exactly. So that's what you're doing. You are hypothesizing why this automatic assessment of an A is possibly not reflective of what we found. Yeah, yeah. So that's why I've written it up like this. Can you see that? It's, that's my first outcome over there. And now what I'm going to do is I'm going to go back to these species and look at what they require. You with me? So what I do is I go back to my assessment, and here is my my information sheet. Now you can leave it the way it is like this, but what I generally try to encourage students and people to do, sorry, I didn't pick up the trout, is to improve it slightly. I really encourage people to clean it up a little bit so that you can use it a lot faster, so that you can see what's going on. And that's just fast, deep, fast, shallow, slow, deep, slow, shallow, and this is intolerant. Let me just make those wrap text still. Whoopsie. Okay, then you've got O veg. You've got undercut bank. You've got substrate. And you notice that they're only taking those that are high. Aquatic veg. And then this is depth column. And then here you've got water quality tolerances. So what I've done here is in terms of the flow intolerance, you can see that the scores, what Niels has done is he's just categorized highly intolerant to very tolerant. But the scores go from 0 to 5. Can you see that? So I'm going to replace, I want to get rid of all of my false. Sorry, it's stuck on the screen. So here I want to take away the false. I want to replace it with nothing. Cancel. Just see what's wrong there. Oh, it's a VLOOKUP. Control C, paste values. Okay, now it should say false. Yes. Now I can go find, select, and replace. Okay, let's put it here. Now I can say I want to replace false with nothing. Okay, close. And then here, what I want to do is I just want to is equal to the sum of that, because I want one row. Can you see what I'm doing, guys? Are you guys still there? Multitasking, that's fine. Yeah, that's okay. Just want it to be values. And then, okay. See, now I can delete this. Can you see that? Now I've got a little bit of a better, simpler table with just my species. So in effect, I've just gotten rid of all of the noise. And I just want it to be in the middle. Okay, so these scores are all out of 5. So then I want to just put a color scale there, and also just to see the colors. So I want them to jump out at me. Okay, you with me? And the last thing I didn't do was I didn't add in this migration requirement. Okay, and I think here trout is not included there because it's an alien. And we do love trout, in case any trout anglers ever watch this. And you'll see that trout are actually being incorporated in the study to give us an idea of the state of the system. But we also know that they are also causing their own impact on indigenous species, and we can consider that in the assessment. Okay, so what I've done is I've quickly neatened up that table, and then I'm going to say automated assessment based on preferences of species and in context of available habitats. And there's my table. Just the next page, just so we can talk about it now. Okay, there's my table. Geez, why it's done that, I don't know. Oh, sorry. Come on. Okay, I'm just going to make it a picture for now. So we can just see what we're talking about. Okay, so back to the Frai assessment. Now what we're going to do, can you just see, I just wanted to show you that because now the sheet is not so difficult to see. It's quick and easy to see. The first thing we're going to do is we're going to go through the each metric now. So now we're considering to say what it did automatically is it said what were the response of species with a very high to high preference for fast deep conditions, all the different fast depth conditions, and we'll say based on the species it found, automatically it gave it this rating score. Okay, so in the context of velocity depth, do you agree that there has been a major change? Let me just see if I can show you the ratings. So here are the ratings. So the ratings go from -5, which is an extreme loss from reference, or to +5, which is an extreme increase from reference. By the way, sometimes this Frai assessment doesn't allow you to put negatives in, but because it's relative to change from 0, whether it's negative or positive. If you can't put the negative in, just put it positive. It doesn't change your score. Yeah, it doesn't change your score. But then you must just justify to say that you're actually referring to it being a loss. I'm actually saying it was a loss in that variable. Okay, so the first thing is that the automated score says that you had the responsive species with a very high preference for fast deep. You've had a 3, which is representative of a large increase from reference or a large decrease from reference. Okay, so it's minus. So we've lost many of the species that have high preferences for fast deep. So what I do here is I go back to my data and say, all right, in terms of my fast deep habitat, I should have yellowfish. I should have I should have many species, but I only collected 2 of the 5. Do you understand that? I only collected 2 of the 5. So that would suggest, yes, that there is a problem with the species that have a very high preference for vast deep habitats that we didn't find in the study area. Do you agree with me? But if I go back to the photographs show me that fast deep was very common when we did the assessment. You see, fast deep and fast shallow habitats are very common. And if you look at the video, you'll see as well that even over this cross section where they did the cross section, they're very common. So in other words, by saying that the reason for the change in the fish communities is because of this high loss of species that have a preference for fast deep condition, I don't agree with that. I think that is incorrect, that fast deep habitats are still very common and available in the habitat. You with me? Okay, the last thing I want to argue is that not only are they still available and very common, but they're actually characteristic of this reach. They're characteristic of the site. So here what they're saying is you've had a large loss of species because they've lost fast deep habitats. You've had a large loss of species because they've lost fast shallow habitats, but that's not true because they're there. Then you've had a massive loss in habitats, slow deep and slow shallow habitats. Massive, hey, look, it's -5s, hey, which is extreme loss. Why? Because the habitats have been lost. And the question is, no, those habitats were not there anyway. Do you understand that? Those species are not they don't commonly occur there. At this point, you would say, okay, but you're arguing that these species do occur there. They're not very common. They do occur there, although they're not very common. That you should consider the fact that and this assessment does know that their weightings are quite low because they don't occur there very often. But you could just consider that these ratings have changed. Okay, so before we get there, so now we know we got to change this. That's what I'm trying to explain to you, is that we want to change this because we don't agree. The thing that we start off with is we look at, in relation to the diversity of species we find and the different types of habitats that are available at the site under reference conditions, pre-development, because sometimes you'll go to a site and it's been dammed up or inundated because of a dam, and you would assess the importance of that site based on existing habitats. No, you've got to do your site assessment based on what the sites would look like historically. Do you understand? So we know that in terms of habitat, this river still looks like a mountain stream. And based on the different species we have, if I go back to that sheet, you can see that the vast majority of species prefer these fast deep, fast shallow habitats. And if I actually look at the preference scores, fast shallow is more important than fast deep, although it's still important. But then slow deep and slow shallow habitats are important, but you don't actually find them there. Are you with me, guys? You don't find them there. They're not a very common habitat type. Okay, so this is very uncommon, by the way, but what I would do here is I would list fast shallow as being number one, the most important biotope for this reach. Then I would list fast deep as a number two, and I would list slow shallow number three and slow deep number four. Slow deep is the most uncommon habitat that would occur there. Now, if you start with this assessment, you have to give it a weighting, and you have to always have to start with one. If I gave it, if I did 1, 1, 1, 1, then all of these weights would be the same. You understand? Because they're all 1. If I say they're all equal. Okay? But now what I'm saying is 1 and 2, you could even do it like this. You see, you could even go say 1 and 2 are very important. Do you understand? Okay, but what I'm going to do here is I'm going to say fast deep is not as important, and I'm also in my mind thinking that during low flow periods you won't have as much fast deep, but fast shallow is always very important. Now, in terms of the weight, in relation to the importance of fast shallow, how important is fast deep? So you go back to your species list and you realize it's actually very, very important. It's probably just, it's very important, but just not as important as fast shallow. So I'm going to say in relation to my 100, I'm going to give that a weight of 90. You see, it's not as important as fast shallow, but it's still pretty high. If you gave it a weight of 80, that would be fine. Do you understand? Okay, then slow deep conditions. How common are slow deep conditions in our study area naturally? They are rare. Rare. They don't occur there very often at all. And in terms of the species that require those habitats, we do have species that have a high preference for slow deep. But I'm just suggesting that on that reach, those habitats occur somewhere else. And we did not sample them in our assessment. So for our assessment based on our site, I want to say that that is way not important. In other words, I'm not considering that there were fast deep habitats because they're so relatively not important. And for slow shallow habitats, I would say that's probably a 50. You see, if you go in order, it's 100, 90, 50, 20. In other words, I'm saying, consider the fact that they may occur there, but it's very low. The weight of it, the weight of that score, whatever it's going to be, is going to be very low. Are you with me? Okay, so now what we're doing is we're saying, based on our understanding of species that occur there, based on the preferences of those species and the availability of habitat, what is the different metrics and weight those metrics as well. Now I need to give it a rating, so I need to give it my score. Remember what we decided is these scores we don't agree with, okay? So we have had some change in the occurrence of species that prefer fast deep and fast shallow habitats, but in terms of the availability of habitats there, those habitats are still there. They are very common. So I must say that there is a change, but the score, the effect of the loss is not so, it cannot be attributed to this issue. The reason why I'm not getting my fish cannot be because I don't have fast deep and fast shallow habitats. Because if you look at the pictures, they are there. Are you with me? Okay, so I'm only going to give this a score of a -1 and -1. Okay, if you said -2 or -1.5, it wouldn't make much of a difference. But I think that there might be a slight change, but the habitats are still there. In terms of fast deep conditions, I've lost all of my fish. I expected some fish that had preferences for fast deep and fast shallow. And if I go back here, I've got none of these. None of these fishes that have these high preferences occur in the study area. So this makes me think that actually, maybe what's happened is that the fast deep habitats have increased. You with me? But if the fast deep and the fast shallow habitats have increased, is that going to influence the species that have high preferences for those habitats? No. That would have been reflected here, where you've rated for labia, for example, you've given it a 3, and then I would have given it a 5. because there would be more, there would be a higher frequency of occurrence of those individuals. Okay, so what I'm going to say here is that -1 and -1 I think is still okay, but in terms of the massive change in fast deep habitats, they were relatively uncommon naturally, but I have lost all of my species that occurred there, so I'm going to give it a rating of -4. Not -5, sorry, -4. And in terms of slow shallow conditions, I still have slow shallow conditions, although they're not very common. Again, if I go back to Rob's assessment, I can go look at his habitat availability sheet, and I can see here that slow shallow was not very common, but it did occur there, and it occurred with overhanging vegetation and substrates. So it cannot be as extreme. I'm going to call that -3. Okay, and why am I only saying -3? Because I believe that the habitats are still there. Do you understand, guys? Okay, cool. Because now that I've done that, I'm going to speed up. So what I'm going to do now is for my sheet, I'm going to say velocity depth metric. No, I want to do it like this. There's my automated, and here is my adjusted. Oh, what have I done? And I've put it in the wrong place. Please excuse me, guys. I was just running ahead without thinking. Oh boy. Let me fix that. Sorry. Yeah. No, it was sorry, 1 1 2 3 4, and it was 100 and 90 and 50 and 20, and I'm saying -1 -1, and I'm saying -3 and no, -4 and -3. Pardon, 1 3. Yes, thank you, Matt. Well spotted. Sorry, I was putting it in the wrong place. This thing on top here is just an assessment of how that variable has changed. If someone does a hydrological index assessment, they will come and change this. Otherwise, don't touch it. Just leave it alone. We are changing automated and adjusted. So this is my adjusted one here. And I want to go back to my table, and I'll paste it. Oops. Paste the picture. And now you can see that the automated assessment gave this metric a score of 69.2, and I've adjusted it to give a score of 32.1. Okay, now what you've got to do is you've got to briefly give an assessment of why. Why did you do this? So I will say here, this assessment is based on the availability of habitat in the sample area, the habitat sample assessment table provided, and the preferences of species. Although land use changes may have resulted in losses of slow, shallow, and slow, deep habitats in a reduction there has been no noticeable. Don't use the word significance because it must only be related to a significance test. No noticeable increase in the frock and abundance of species preferring fast habitats. Okay, because due to I hypothesize that, oopsie, let me fix my spelling. I hypothesize that there may only have been a slight change to fast habitats, possibly increase, and a slight decrease in slow and deep, no, just slow habitats. Assessment, I have rated changes in, I have rated hypothetical changes. I have rated hypothetical changes in the response of the fish community to changes in habitat, to err on the side of caution, because there has been such a large reduction in species preferring slow habitats. I have scored a rate of -4, but due to uncommon, due to how yeah. Yeah, and look, there's a chance that it was forested beforehand, and the natural forest could have been quite extensive and result in like this slow seepage of water. And now that you've cut the forest away, you have much faster runoff, but you would see in sizing. So in other words, I agree with you, but I just want you to think out the box a little bit and say, maybe it was actually a bigger forest before, and now that the bigger forest is gone, the flows may have actually reduced, or the flows may actually have increased with these new plantations. But we know that these areas were grasslands, and with that forest, if anything, it's just going to go down. The flows are going to go down. So I totally agree with you, and you can add that in. But I'm just trying to err on the side of caution to say, what are the possibilities based on what we observed and what we're doing? And this is my hypothesis. If you came into this assessment, you can say that you could say here, comment Bayanda, disagree, flows due to disagree due to upstream what do they call it, flow reductions, stream flow reduction, there is only a possibility of reduced, fast, and deep habitats. Thus amended, adjusted scores as follows. Okay, and then what you could have done is you could have said, okay, this has got to be -2, this is going to be -2, and this is probably going to go up. Eh? You with me? So you could have changed it like that, and then put it over here, and say is it with an I? Eh? Okay. Okay, cool. All right, and then that's the process that you follow. So that was the velocity depth metric. The next metric that we're going to work on now is going to be, and I'm only going to show you these two because what I want to do is I want to do them all and then just show you what they look like, okay, because I don't want to waste too much time. Okay, so here's the cover metric. Cover metric. And then I want to start with screen table for this metric from the Frai included to justify. Okay, guys, why am I doing this? Why am I doing this? I'm encouraging you to do it properly. If you're ever going to do anything, do it properly. So I'm introducing it. I'm going to put in here table 1, and this is going to be automated Frai, automated table. No. Automated Frai score for velocity depth metric for where is it? For assessment of and then I just want to go back and get Rob's. Do you understand what I'm saying, guys? Is this when you write it up, I want this. I want it to be in this type of detail because then you can justify what you're doing and how you did it, and you can publish the thing. Where if you don't do that, then I don't know where it comes from. And if you give this to somebody else, what are they supposed to do with it? Do you understand? Okay, this is table. I'm just doing it quickly just to show you guys that it doesn't have to be so complicated, but you can do it properly. There we go. Okay, and then here, I would go here, Okay, and this will be 3 and 4. And then here, by the way, binder, I'm going to do this.
And I can see that the table, this curve, the absolute average weight, hasn't changed. That's still the finest
No, no. So yeah, and in some cases the change is small. So you're not gonna get that. That sometimes that change is not noticeable. Um, yeah, which was useful. Which yeah, how we got to this, and how we got to this. Yeah. Okay, so then I just want to move this up here so that it's in the right order. You see that? Because you've got to start, then you get table 2, then you get table 3. Do you understand? Trying to do it properly. Table 3 and 4. Now we move to the cover metrics, guys. So let's have a look quickly. So again, what's happened here is this is our automated score, and you can see that the cover metrics are also considered to be a massive problem. And if we go back to our species, what did we find? So here we've got cover preferences for overhanging vegetation, substrate. Can you see that? That substrate column is by far the most important. I would do substrate first, then overhanging veg, then aquatic vegetation. See? And then undercut bank slightly. But I mean, there's a major drop off after substrate. Can you see that? Okay, and that's representative of the type of habitat we're working with. So what I would do here, let's delete that, is I would go substrate type is 1, overhanging vegetation is 2, 3, 4, 5. And what is that ranking based on? It's ranked on based on this. 1, because they have very high preferences and there are so many species. 2, 3, 4. And then water column the last one. And water column the last one, I don't think you can give it a 0. Can you? I think it did actually. Yes, you can give it a 0. Okay, so 1 must always be 100. But here I'm going to show that it drops off very quickly. So I'm going to go 60, 50, 40. Can you see what I'm doing? I'm saying that this substrate type is particularly important. See, and here they've even dropped it off much faster than I have. They've gone right down, but I think that that's okay. It's still important, especially overhanging vegetation and undercut banks. In-stream vegetation could be very small as well. And based on the assessment, I don't expect there to be much in-stream vegetation. Can you see that? So this aquatic veg is important, but I really don't expect to find any. So what I'm rather going to do is I'm going to go 4 and 4. I'm going to change those to 4s and I'm going to make them both 30. Undercut banks and that 30 as well. Okay, then I go back to my species, and again, what do I expect? So I got species that have preference for substrates, but I got nothing for overhanging vegetation, nothing for all the others I didn't find. I only found 2 species that have a high preference for substrates. Then I go back to the video, and what do I find again? I find overhanging vegetation, lots of in-stream substrates. Can you see that? Okay? So what is causing the changes again? So I'm going to argue again here that what is the response of the species with a high to very high preference for a particular substrate? They are available. So I'm going to say that's a -2 only. Okay, this is one of those situations where it doesn't like a negative. What about, we can actually start from the top. What about the preferences for overhanging vegetation? Has there been a change in species? I did have some species and I found nothing. But how has the overhanging vegetation changed? Well, it's abundant. Can you see that? So it cannot have had much of an impact. I'm going to keep it low. I'm erring on the side of caution by not saying 1, but I'm going to keep it low. What about undercurrent banks and root wads? I think that there may be a slight change, but nothing as excessive as what they suggest. And at -2 again. Just if I can put a minus in. No, it doesn't want it. So I'll just put a 2. And a 2 there again. In-stream vegetation. How much change has there possibly been for in-stream vegetation? I don't know actually if there's been a loss, but I know that with the high velocities you don't expect there to be too much. And I've lost most, I can't tell because I haven't seen this. So I'll say that's a 3. And the water column is still there, but there's no fish there. So it won't change it.
You're referring to last time about increases in vegetation.
No, because my species, there are no increases in species. So I'm always saying there's a reduction in species that have a preference to this because of a change. So it would be negative, negative, negative. So by the way, guys, can you see that I've put positive 2s because my scores will be the same, but in effect, it's actually reductions. Do you understand that? Okay. That's an issue with Frai that we've known for a while. Okay. 74. And my changes. Does anybody disagree? 42. Okay, so what I'm going to do here is I'm just going to copy paste those tables, references. Fix that now. Just want to make sure it's still looking right. Okay, automatic Frai score for, this is cover. Okay, no by-under comments this time. That was table 4, hey? 3. This is 4, and this is table 5. Table 3 and 4 include results for the metric of the fire justifier changes, and this is going to be table 4 and 5, and this one, by the way, is 1 and 2. Yeah. Okay, what are we arguing again? So let me just put the automatic score there. No, I want to keep it on the next page. And then what are we arguing? We're saying that based on availability of cover features associated with preferences of species, and okay, because that's something we must consider as well, is that there was some change in the major change was in species that have got these high preferences apart from substrates. Can you see that? So if I go back here, I still found some of these guys. I didn't find any of the others. Okay, but it is there. So I've got to say, based on availability of cover features associated with preferences of species for overhanging vegetation, hypothesize that there may only have been a moderate change in communities due to changes in cover. There possibly has, and then substrates, and this is, I'm referring to cobbles and boulders, have only are abundant, and hypothesize the sized not to be the cause for changes in fish communities. This okay, great. So guys, I just wanted to show you quickly. Let's not jump ahead there. What I'm going to do now is I'm going to do the flow modification one, the physical chemistry one, the migration and the introduced species quickly on my own. And then I'm going to just go through them quickly to show you what I've done. So in other words, I don't want to waste time on the recording to do them all. And then I'll come back and we'll talk about all of them. Is that okay? So give me, because it's almost been 2 hours already, give me 15 minutes, okay? Okay, bye. All right, so what I've done now is I've just gone through the rest of the metrics, and you'll see each metric now has a automated score, and my adjusted score. And I just wanted to go through quickly what I've changed. So I want to speed up a little bit. The next one is to look at these flow-dependent matrices. And this is based on the observed and derived data with reference to flow dependence. How will the following change? The species, and this is all when flows cease or they reduce significantly in a system, how do the species respond? How vulnerable are those species to those changes? And if you look at our reference list, you can see over here this flow intolerance, that our Chiloglanus is totally intolerant to changes, to stops, to no flow conditions. That means if the flow in the rivers stop and they've got pools left, this species will probably not survive. Do you understand? So if it's happened, the first species you expect to leave or to go will be your Chiloglanus and your Amphilis. We've lost the Amphilis, but you definitely still have lots of Chiloglanus. So the issue there then is it's not this flow intolerance thing. So what I've done as a result is said, okay, what is the response of the species to no flow conditions? And erring on the side of caution again, I've suggested that there's been a slight change because I've lost Amphilis only, and then probably a slight change to the rest. But you would have lost this one first. So I don't have enough data to say that there hasn't been a slight change at all, that there's just been a moderate loss. In fact, I would probably just say that there's been that it's been -1s, and the reason being is because I can assume that there's been a slight change, but I can't, because the Chiloglanus are still there, that are highly sensitive to this. It must still be okay. Okay, does that make sense to everybody?
Yes.
Okay, so I'm quickly just going down to that one again. Flow modification. This one. Okay, and then my argument is to say, based on the intolerance of C anotis to no flow conditions, but continued occurrence, the fish community is hypothesized not, oopsie, is hypothesized not to be responding to increases in no flow conditions. Okay, why is that adjusted just one? Yeah. Rank ratings have all been set to a small reduction to err on the side of caution. Right. And this is table 7. That's this one. All right, then physicochemical metrics. Very similar here. What we have here is, again, it looked as though there was a huge change. And if you looked at the species and the vulnerability to changes in water quality, you had species intolerant to modified, so they're totally intolerant to water quality changes, all the way down to species that are tolerant of water quality changes. So you expect those species that are intolerant to be the ones that would change first. And if you look at our species again, which species have got those preferences? So we're looking at this tolerance one. You can see again, Chiloglanus onoturus has got a very high tolerance. The trout have got a very high intolerance, not tolerance, sorry, intolerance. So it's the Amphileus, the Chiloglanus, and the trout. But we found Chiloglanus. So again, there's this issue of they are not the ones responding. So again, I reckon that the ones that are totally intolerant and moderately tolerant are as important as each other. If you look at this table, so I'm considering those and these that are 3s that are just as important to make sure that they're maintained in the system. High diversity, relatively high diversity of species for both components, and those are the ones that are more vulnerable to change. So I've suggested that because of the Amphileus, there's possibly a chance of a small change, but there's definitely no way that the rest of the species would be responding to modified water quality because Chiloglanus is still there. Do you understand? That's what you need to look at. The question is, are the species responding to changes in water quality? And the fact that some of the species, so 2 species expected to occur in the Sabi River at this site have very high intolerance ratings to altered water quality. Okay, this includes cyano that has been observed from the study. Based on the preferences of this species, we hypothesize that there may only have been a small change in water quality conditions. Okay. These changes may be indicative of the absence of AURA from the assessment. Okay, so that's what I'm suggesting, that there's only possibly one small change, and that's affected this Uranoscopus, and that's why there's a -2 compared to the rest. Then if you look at system connectivity and impacts on connectivity metric, what I've done there is the first thing I did was I looked at whether or not there's a chance of causeways, impoundments, and physicochemical barriers. And what I did is I went back to the study area, and starting at where we were sampling, I went downstream to see, is there a possibility of any chemical or physical barriers? And you can see this is a very rough way of doing it. There's a possibility of some barrier over here, a bit of a natural barrier over there. There's pipes and things, but that's not too serious. But then as you come over here, I think this is the first place where there's a possibility of a causeway that may be causing an obstruction. And because of the wastewater treatment work releases, I suspect that there may be a water quality issue over here downstream. that may be affecting the upstream migration of species. So that may be something that's causing species to come down and they can't get back up again. Do you understand? Are you with me, guys?
Yeah.
Okay, and then here's another one where there's a bridge, and it just seems like this bridge is built into this rocky area, and I don't know if there's causing a barrier because it looks like there's flows coming off it in different directions. So there are a few obstructions, and as a result of those obstructions, I've argued that it can only be a small to limited change, but that there also is possibly a small to limited change in the water quality. And I think if anything, I would like to change that to a 3. And that's my assumption that the wastewater treatment works are not functioning as well as they should, especially in a system where you have so many species that are vulnerable to water quality changes and need to migrate and may need to migrate upstream. So that may be what's causing the issue. For this assessment, we considered the existence of physical barriers and chemical barriers in the region associated with the site. Only the partial potential barriers it's only possible partial physical barriers were observed using Google Earth, but the large waste water treatment works downstream may be affecting water quality that may affect connectivity of local features for some species. Okay. So that's the argument, is that that's the only possibility that may be causing this problem. Table 10. Okay, then the last thing is to look at this introduced species impact. And the question here, metric. The question here is, do you think that the historical occurrence of trout may still be having an impact on the fish communities in the study area? So the first thing you do is you rate what species may occur in the study area, and the only thing that we think can occur there is trout, and that's because they've been collected historically, and it's also because the river is considered to be a this part of the Sabi River has historically been stocked with OMYK and is still considered to maintain a population of the species of this alien species. You with me?
Yeah.
Okay, then you've got to consider when you do your assessment then, is you consider in terms of the potential effect of alien invasive species, you consider not only do they occur there, but what is the abundance. Now, why would you say this? It's because a species like a bass or a trout that predates on other fishes, the fact that it occurs there and there's only one of them is never as serious as the fact that there are thousands and thousands of them. Because if there are thousands of them, they can come in and wipe out the whole population. So if the system itself restricts the expansion of the population, and you're always going to have a few individuals, then you're never really going to have an impact of alien invasive species. But if the alien invasive species have the ability to proliferate and predate and increase their predation because the population is growing, then there's a problem, because they would be able to completely destroy indigenous populations. And that's where, for example, from a habitat modification perspective, if you've got one carp in a dam, or a few because they don't have enough food, or they don't have spawning habitats or whatever it may be, which is slim, then you're not going to have a problem with carp. But as soon as you get thousands of carp that then start disrupting the habitat, they start affecting the whole ecosystem. Does that make sense? So you're looking at the difference between widespread, how widespread, and what is the frequency of occurrence of these competing or predaceous species, over what is the potential impact of them predating on indigenous species. And we've only got trout there, which is I've considered to be with a rank of 1 and 2, and I've just given it a rating of 2 to say that there's a possibility that there's been a slight, a small change from reference in the fish communities because of trout. Okay, so then the argument here is just to say these OMYK are yeah. Yeah, you need to hypothesize. So here I must actually say this part of the Sabi River has historically been stocked with trout. Okay. Look, and we hypothesize that they still occur we hypothesize that that a population is being maintained in this river. Okay, so the question here is, guys, is what is the potential effect of trout? And we know that they can be quite destructive if species are vulnerable, especially in these flowing habitats where you've got limited slow deep habitats and things like that. And I think historically, maybe it's the trout that's actually caused a lot of the indigenous fishes to reduce in abundances. Because I know I've collected trout that are full of amphilis, for example. I've also collected trout who have been very effective predators of Barbus anoplis. That's in the Elands River area. So I definitely think that there's a possibility. Are considered to pose, I'm not going to say limited, I'm going to say they are considered to have a threat to the indigenous populations of fishes. Although OMYK have not historically been observed in high abundances. So here to err on the side of caution, we rate their impact to be moderate on the local community. Does that make sense, Pateni? If you find it, you would rank it very low, unless you think that there's a chance that they are the things that have completely removed indigenous species. If you think that they are the responsible for removing all of your indigenous fishes, and now their population has declined as well. Because remember, as soon as they eat up all the fish, they're not going to have much food left. So in some cases where you've had these huge explosions of alien predaceous species, they smash all the indigenous fishes. It's like what you see in the Cape. And if you go there now, there's very few bass. there's very few aliens, but they've already destroyed a lot of the indigenous species. And that period of boom when they were all growing because there was so much food has passed. And now there's no indigenous fishes. So you've got to use your discretion and just justify what you were saying. Do you understand? All right, so that's the last assessment. Now the last thing that you need to do is you need to put a balance. You need to weight the different metric groups. So after the assessment of each, after the reassessment, let's call it adjustment, of each metric. Oh man, my typing is shocking today. After the adjustment of each metric, the relative weighting of each metric component relative to other metrics has been evaluated and populated in the Frai assessment base. Okay, and that's going to be this table 12. So what I've done here, guys, is I've now argued what is the relationship between, what is the weight out of 10? If you can say it's a maximum of 10, what is the relative importance of cover compared to velocity deep? So I'm saying velocity deep is slightly more important than cover. So I've given it a 6 and a 4. How about velocity depth and flow? 5 and 5. Velocity depth and water quality? I'm saying velocity depth is slightly more important because water quality change has a slight impact on the dilution. Just hold on, someone's knocking on my door. Give me a second. Okay, so in this case, what I've done is I've just put the different ratings, and I think the important ones to consider is why would velocity depth be more important than physicochemical quality? And I think here the weight of velocity depth rated slightly higher than water quality due to dilution potential. In other words, it's part of the dynamics of the system that I'm considering. Dilution potential. And relative importance of velocity depth of VD metric for species compared to water quality. Okay? Anything else that's important? Cover and flow is the same. Cover and water quality. I've said water quality is slightly more important. Cover and migration. Cover is more important. Flow, physicochemical is the same. These are no flow. So if you've got no flow conditions, then water quality becomes a big issue. Does that make sense? Because then you don't have the dilution. Flow and migration. Flow is more important. How about this? Physicochemical and migration. That if you don't have a habitat to migrate to, migration doesn't matter. And then physicochemical versus introduced impact is species, and migration versus introduced species. That if you can't get there and or if the habitat's not suitable, then these guys don't matter, and that would affect them out as well. So that's, I think, sufficient for that. So here's the final outcomes. Include a summary of the relative weightings of different metrics considered in the study, and that's table 13. Okay, that's what this is, just to show you what they are. And more importantly for us, if we go look at the summary, whoa, look at what's happened. So we've suggested that the automatic score was an E with a score of 29.8, and we now show that the adjusted score would result in a score of 63.2, which is a C category. Can you believe it? Does everybody understand that? Okay, let me just put that in our little report. Okay, so the automated Frai score is 29.8. 29.8. Is that what we got up here? Yeah, I think I just need to update that a little bit. There. Which is a class F, it said. I think it said it was an F. E. And then when we did the adjustment, after adjustments to the Frai, the automate adjusted the new scores, new Frai score is equal to 63.2 class C. Okay, do you see that now? So now what we need to do is we need to include some closing remarks. Why do you think there's such a discrepancy? Yeah. Well, remember that they didn't just give us presence absence. They gave us abundances, which gave us an idea of the frock, the frequency of occurrence. So you know what's the issue here? I mean, we expected 1, 2, 3, 4, 5, 6, 7, 8, 9 species. So from this assessment, yeah, give it a go. From this assessment, we evaluated we determined a Frai score of 63.2%, which represents class C or moderately modified fish community state. This outcome is based on the adjusted Frai score that differs notably, considerably. Please resist the urge to say significantly, okay? Don't use the word significant because you have to do the test. So this differs considerably from the automated score. Okay, the reasons, the drivers of this discrepancy is the drivers. So the drivers of this discrepancy is the low diversity of species sampled on the, when was the date here again? On the 20th of February. The drivers of this family is low diversity of species sampled. So they collected a very low diversity of species on the 20th of February that do not see the fact that you've got low samples that does not not correlate to changes in environmental conditions observed in the system which Frai evaluates. As such, okay, this includes the effect of what I'm trying to say here is that the drivers of this discrepancy is the low are the low diversity of species. And how many did we get? Sampled on the 25th of February that do not out of an expected diversity of n equals 9. And why? Because the fact that we got so few species, they do not correlate to changes in environmental conditions observed in the system which Frai evaluates. What this means is that although there were only two species were observed, the state of the system does not cannot be although only two species were observed, the state of the system does not I don't want to say physical chemical because that's one metric. Although only two species were observed, the environmental conditions should be suitable to maintain many more species. Okay. Is hypothesize. Do you understand what I'm trying to say here? To reduce this uncertainty, the sampling effort to reduce this uncertainty, the sampling effort and number of sites needs to be increased. In other words, we're to test the hypothesis that more of the expected species do still occur in the reach of the Sabi River. Do you understand what I'm trying to say? That's what you need to do. To reduce this uncertainty, the sampling effort and the number of sites needs to be increased in monitoring assessments to test the hypothesis that more of the expected species still occur in the reach. And which reach am I referring to? I'm referring to this reach of the Sabi River. Can you think of anything else? What else could I do? Okay, different sampling techniques other than the use of an electrofisher alone should be considered. Okay, and then what do you say? Do we say anything about the actual state? Are we going to say that you should use this class C? Huh? Hold on. But for management. For management and formal monitoring. Say that again, Matt. Yeah. Yeah. Hi. Um, so it's the drivers of the change in the state of the fish community can be attributed to changes, to potential changes in. And then if you go back to Frai, you can see where they give you the summary. That's just your weightings, but it doesn't give you all of your scores. Weight. Thought that you used to get your scores here. I think I may be using a slightly older version. So migration is 68. Physical chemical is 21. 20 for flow. Velocity depth is 32. Yeah. So drivers, environmental drivers, from a pristine class A to a moderately modified class C and this is what we expect, and this is what we observe, can be attributed to potential changes in velocity, depth, metrics. That was the most important one, I think. Velocity, depth, cover. Oh yes. Let me put them in order of importance. In cover, velocity, depth, migration, okay, what do we think should be done? Let me just look at the introduced one. Oh, that's also not too quite high. Okay, so we recommend what do we need to do to improve the quality? So we recommend improving the state of the system so that these species can return. We recommend rehabilitation of no, we can't really. Yeah, mitigation measures associated with upstream stream flow reduction associated with um, um, forestry and local water quality and agricultural Okay, we recommend mitigation measures associated with upstream stream flow reduction activities due to the forestry sector be implemented and local water you've actually got to say be evaluated and no be implemented mitigation measures be implemented and local water quality altering activities such as the waste water treatment works downstream of the study area be image. Okay, and the problem with this is that how sure are we that this really is the problem? So we got to say it's potentially associated with upstream and local water quality altering activities, possibly including C. Here we go. Yeah, it's tough, eh? Because these type of rapid assessments are rapid, and it's difficult when you are trying to it is difficult when you're trying to make a very formal assessment, but you're using tools that are not they're robust, but sometimes you prefer to just go back to good old statistics, especially when you don't have a lot of the data. Yeah, let's just save it quickly. Let's just save that, and then we're gonna just save our Frai assessment quickly. No, no, and I think the problem is you're not even accurate that you have a C here. But what you did have was you had data on Chiloglanus anoterus. You did have data on the yellowfishes, and you can start looking at community structures and things like that. And even if you have to do rapid assessments, sometimes the anoterus itself is such an important indicator that it can tell you a lot about what's going on with the system. You don't necessarily need to go and find all of the other species, but using this Fry assessment, it relies so heavily on multiple species and a better representation of what a species actually occur there, that you have to start making these assumptions of what could possibly be driving the community. And as soon as you stop relying on the species that you observed, you start to incorporate uncertainty, which starts to mess up the information. So this may be a good case study where here you could recommend just focus on the Chiloglanus onotrus community and then find out what's going on, or population, and then find out what's going on with the other species, and that may be suitable. Yeah. And when you do your assessments, try to get as good a representation of what could be in the system as possible. It's very, very important. Very important. All right, guys. I hope that this has given you enough to allow you to start trying to implement Frai yourselves. And what I really want you to do is I would like you to have gone through an assessment like this and write it up in a similar format. There are other formats, there are other justification tables that you can use. I know that Wesley Evans, the MSc student, in his thesis has used another format which was great. And Pumla Dlamini has adopted that similar structure which you can use to justify your adjusted scores. I haven't used Frai 2.0, and what Frai 2.0 is it takes away our ability to adjust some of the velocity, depth, physical, chemical metrics and things like that. And what it rather does is it argues, based on our assessment, can you go and justify whether those species actually don't occur there or not? So in other words, if you looked at this, the species we found, if you looked at the assessment we've undertaken, there's actually a much higher probability that you're not really going to find the others there because of the habitats we sampled, or that they actually do occur there, and you would actually include that in your assessment to say that you actually think that they do occur there. So Frai 2.0 uses a slightly different approach. I don't mind the adjusted assessment part of Frai 1 because at least I can tell you exactly what I've done. And you can go back and you can fix it later if you get new information or something. And I can actually direct you towards the uncertainties in certain areas. But for your work, please can you do your multivariate assessments, and where you get the multivariate assessment trends based on your community structures and shifts in community structures with your statistical assessments, rather than go back and see whether it correlates to what you're getting with Frai. You can even include the Frai scores as a explanatory variable in your multivariate assessments and see whether you get a significant association between your automated Frai scores and your adjusted Frai scores and your community structures. I think that would be pretty cool. Thanks, everybody. Will you please give it a go? Just give it a go. That's what we want you to try and do. Is that okay, Mpateni? Okay, fantastic. Yes, what about it? I'm going to upload the video and then I'm going to send you a copy of the report. Okay. All right, guys. All right, thanks very much. It's been long, but I think it's been useful, and you guys can go watch the video whenever you need it. All right. Thanks, everyone. Okay, bye now.